So in this video we're going to take a look at the subtraction formula and we're going to try to basically derive it based on this figure, this geometric figure. You can see that I have two triangles over here, AGF and AFD. So these two triangles, one of them is here, the other one is here, so this one is basically on top of the bottom one, and you have here two angles alpha and beta. And so the subtraction formula derivation, the subtraction formula basically says that when you have such two angles like alpha and beta, then sine of alpha plus beta, the two angles together, is equal to sine alpha cos beta plus cos alpha sine beta, and this is number one. Number two, cos alpha plus beta, cos of the sum of the two angles, is equal to cos alpha cos beta minus sine alpha sine beta, and this is number two. So now in order to derive it from this based on this figure, basically there are a few steps that we have to go through in order to get to these two formulas. So first of all, you have a straight line in this figure, line AB, and you just let the straight line AB revolve to the point C and sweep out the angle alpha. So now we have the angle alpha here, and then you let it continue to point D, the same line continue to point D to sweep out angle beta. Now you need to draw a perpendicular DE to AB. So DE and AB are basically now DE is perpendicular to AB. So you can basically, this is 90 degrees. Next, basically you know that this angle over here, sine alpha plus beta, so if this is basically alpha plus beta, then sine alpha plus beta is this length DE divided by DA. So now you know that based on the figure, sine alpha plus beta is equal to DE divided by DA, because it's the opposite divided by the hypotenuse. And cos of alpha plus beta is basically the adjacent, which is AE, divided by the hypotenuse, which is DA. So that's basically the sine alpha plus beta and cos alpha plus beta. Now you need to draw a perpendicular. I've already done the whole figure, but now I'm just telling you step by step how I've done this, or how you're supposed to do this. So you draw a perpendicular DF to AC. So now you know that this angle over here, this is basically 90 degrees. This is 90 degrees. Let me So this is 90 degrees and this is 90 degrees. So basically DF is perpendicular to AC. And you draw a perpendicular FG to AB. So this is also perpendicular. And FH perpendicular to DE. So this is also perpendicular. Now, based on this figure, you have the angle alpha here. And based on this figure, we can prove that this angle over here is also equal to alpha. I'll tell you in a minute why. And the reason is the straight line AC. So the straight line AC, this line is, let me do it in another color. You can see that this line HF and the line AB are parallel. So if I continue this line like this, and this line like this, and this line like this over here, and this line like this over here, so now you can see that this line, these two lines are parallel, and this line AC crosses the two parallel lines. So now you can see that this angle alpha is equal to this angle. So this is also alpha. So this is alpha, this is alpha. And so this is basically, and this is 90 degrees over here. So this is also 90 degrees because this whole thing is 180 degrees. So now, whatever this angle over here is, DFH, whatever the value of that, I mean, whatever the value of this angle alpha complements this angle. It means that angle DFH plus angle FHFA, these two angles together, they'll be 90 degrees, right? And now if you move into this triangle over here, you have an angle 90 degrees, and you have this angle alpha and this angle over here, which is DFH. Now in this triangle, the angle DFH complements this angle over here, because these two angles together, added together, would be also 90 degrees, because this is 90 degrees and the internal angles in a triangle is basically adds up to 180. So this angle 90, so these two angles together must be 90. So because this angle complements this angle and this angle also complements this angle, so these two angles HFA and HDF must basically be equal. So if this is alpha, then this is also alpha. So that's how you know that this angle is, this alpha is equal to this alpha over here. So next, what you need to do, now you know that the length ED, which is this length over here, is basically equal to HE plus HD, but HE is equal to FG, so you can say that this length ED is equal to DH plus FG. So ED is equal to FG plus HD. Right? And So here we said that sine alpha plus beta is dE by dA. So I have a dE over here. So if I basically write sine alpha plus beta is equal to dE divided by dA, then I can replace this whole thing, this dE, by fg plus hd. So this is equal to fg plus hd divided by dA, and so this would be equal to fg divided by dA plus hd divided by dA. Now fg divided by this length divided by dA, so now you got this. Okay, now we need to somehow get this thing over here. So now you can see that fg, if you want to get basically what's sine alpha here, if you were looking for fg as well, so fg divided by fa is what? Is sine alpha, right? This, the opposite divided by the hypotenuse. So you can basically somehow bring in fa as well, right? So you can write sine alpha plus beta is equal to fg divided by what? Divided by fa, and then you have, since you have divided by fa, you have to multiply by fa here as well, and then you can write dA here as well. So now you have multiplied and divided by fa plus now if you pay attention to what you got here, fa divided by dA, fa divided by dA, this is basically cos beta, and this is exactly what we needed here. Now hd, now what is cos alpha here? Cos alpha is basically, well, we have hd here, so hd, so this is something about beta. Now df, so let me see, if you have hd, so you have alpha over here as well, so you can say that hd divided by fd, these two sides over here, this would be cos alpha, and this is cos alpha over here, right? Well, I'm running out of time here, so let's do the rest of this video in part 2.